Have you ever wondered what life might be like if the conditions for its sustenance were drastically different? Picture this. Instead of our familiar world, where life relies on oxygen and a moderate range of temperatures, we find ourselves in an entirely different scenario. Life, as we know it, is a delicate balance. The Earth's atmosphere is composed of roughly 78% nitrogen and 21% oxygen, with traces of other gases. Oxygen, as we know, is vital for our survival. It plays a crucial role in the process of cellular respiration, enabling us to convert the food we eat into energy. Moreover, the Earth's average temperature sits comfortably at about 15 degrees Celsius, a range that supports a diverse array of life forms. From the frosty poles to the sweltering equatorial regions, life has found a way to adapt, survive and thrive. But what if the rules were rewritten? What if, in this alternate reality, sulfuric acid replaced oxygen as the vital gas for life? Sulphuric acid, with its pungent, irritating smell and corrosive nature, is far from what we'd consider life-sustaining. Yet, in our hypothetical world, it's as essential as oxygen is to us. And let's not forget temperature. Imagine a world where the optimum temperature for life is a scorching 80 degrees Celsius. That's hotter than the highest temperature ever recorded on Earth. In this environment, the gentle warmth of a summer's day is replaced by the intense heat more akin to a baker's oven. These conditions seem extreme, even inhospitable. But remember, life is tenacious. It has a knack for survival, for adaptation. So in this world of sulfuric air and searing heat, life finds a way. It may be unrecognizable to us, with bizarre and fantastic forms unlike anything we've seen before. Now hold on to that thought. Let's dive deeper. Let's explore how these new conditions might affect life forms and their survival strategies. Imagine a world where sulfuric acid, a corrosive and dangerous substance on our Earth, is as vital as oxygen is to us. In this bizarre and intriguing world, the rules of life as we know them would be rewritten. So, what might life look like in such a harsh environment? Well, let's dive in and explore. Firstly, to survive in a sulfuric environment, life forms would need to evolve biological structures that can withstand the corrosive nature of sulfuric acid. Think of a protective barrier, similar to the waxy cuticle on a leaf, but far more resilient. This barrier would prevent the acid from eating away at the organism's tissues, providing a shield that would allow life to exist in such extreme conditions. Now, breathing in this world would be a whole different ballgame. Instead of inhaling oxygen and exhaling carbon dioxide, the creatures of this world might inhale sulfuric acid and exhale, well, something else entirely. Perhaps they might even exhale sulfur dioxide, a gas that results from the reaction of sulfuric acid with organic matter. To further adapt to this environment, life forms might develop specialized filtering systems. Picture a creature with a biological filter similar to a gas mask that can separate the harmful components of the acid, leaving only the useful sulfur. This would allow the organism to utilize the sulfur, a key component of proteins and other essential biological molecules, for its own growth and development. Moreover, these organisms might not just survive sulfuric acid, but they might thrive on it. They could potentially convert the acid into usable energy, much like plants convert sunlight into energy through photosynthesis. In this sulfuric world, a process analogous to photosynthesis, but with sulfuric acid as the energy source, could be the norm. Indeed, life in a sulfuric world would be radically different from anything we know. From developing acid-resistant barriers to evolving unique breathing and energy conversion mechanisms, survival strategies in this world would be as fascinating as they are alien to us. The adaptation to a sulfuric atmosphere would certainly redefine our understanding of life. What if the optimum temperature for life wasn't a balmy 37 degrees Celsius, but a scorching 80 degrees? Picture this. A world where life thrives in what we'd consider an oven setting. Sounds unimaginable? Not quite. Let's delve into the possibilities. In such a world, life forms would have to significantly adapt to this sweltering environment. The first thing that comes to mind? Advanced cooling systems. Imagine organisms with built-in biological air conditioners. These cooling systems would work tirelessly to keep the organism's internal temperature at a bearable level, possibly by circulating a heat-resistant fluid throughout the body. It's akin to how elephants use their large ears as radiators, but on a much grander scale. But what if surviving these temperatures wasn't about cooling down, but about embracing the heat? Life forms might evolve to become more tolerant to high temperatures. Picture organisms with proteins and enzymes that don't denature at 80 degrees Celsius, but instead function optimally. These heat-loving beings would be a testament to life's resilience and adaptability. However, these adaptations wouldn't come without a cost. High temperatures increase metabolic rates, meaning these organisms would need a vast amount of energy to survive. Finding food would become a high-stakes game, a constant battle against the clock. Reproduction, too, would be a challenge. With such high energy needs, would there be enough resources left to reproduce? And if so, how would offspring be protected from the searing heat? Surviving in such conditions might also require a shift in behavior. Nocturnal lifestyles could become the norm, with organisms seeking shelter during the day's peak heat and emerging at night when temperatures are slightly cooler. In the grand scheme of things, life at 80 degrees Celsius would be a constant struggle, a balancing act between staying cool, finding enough energy and reproducing. But it's not impossible. Life, as we've seen time and time again, has a knack for thriving in the most extreme conditions. Life at such extreme temperatures would indeed be a fiery existence. In this sulphuric heated world, how would ecosystems function? Welcome to a place where the rules of life as we know it are rewritten. Here the food chain is not so much a ladder as it is a web, intricately woven around the necessity to thrive in an environment that's both scorching hot and filled with sulfuric acid. First, let's consider the producers, the base of every food chain. These would be organisms evolved to photosynthesize using the sulfuric acid in the atmosphere, not unlike how certain organisms on Earth use sunlight. They would have to be heat tolerant, thriving at temperatures that would cook most life forms we're familiar with. Next up, the consumers, creatures that feed on these producers. They would likely be hardy, acid-resistant beings with digestive systems evolved to break down the acid-rich organisms they feed on. Imagine creatures with metal-based shells or scales to withstand the heat and acid. At the top of the food chain, we'd find predators adapted to this harsh world in their own impressive ways. They might have evolved mechanisms to neutralize the acid in their prey, or perhaps they've developed a taste for the acidity. Biodiversity in this hypothetical world would be a fascinating mix of the strange and the extraordinary. Life forms would be molded by the necessity to survive in an environment that's both acidic and heated, leading to a variety of unusual adaptations and survival strategies. Symbiotic relationships would likely be a key feature of this ecosystem. Some organisms might evolve to neutralize the acid or heat for others, offering protection in exchange for food or other resources. Imagine a creature that secretes a substance that neutralizes sulfuric acid, acting as a living shield for a more vulnerable species. In this ecosystem, the fight for survival would lead to incredible evolutionary leaps as organisms adapt to their hostile surroundings. The result? A world teeming with life that's as diverse and complex as it is resilient. Such a world would host an ecosystem as fascinating as it is alien to us. This sulfuric, heated environment, as harsh and inhospitable as it may seem, could indeed be a cradle of life. Just not life as we know it. Our exploration of this alternate world brings us to a profound realization. In the realm of what could be, where sulfuric acid replaces oxygen and 80 degrees Celsius is a comfortable room temperature, we find life forms that defy our conventional wisdom. They are not merely surviving but thriving in conditions that we would initially deem inhospitable. Consider for a moment the organisms that have adapted to breathe sulfuric acid. Their respiratory systems would be vastly different from ours, perhaps featuring unique filters or protective layers to cope with the corrosive nature of their life-sustaining element. Life that thrives at high temperatures, too, would need to develop extraordinary coping mechanisms. Maybe they'd have heat-resistant skin, or perhaps their cellular structure itself would be radically different from ours. The adaptations don't just end at the individual level, they'd ripple through the entire ecosystem. The flora, fauna, and even the microbial life would all have to evolve in tandem, creating a harmonious, if somewhat alien, symphony of existence. But what does this mean for us? This thought experiment forces us to question our preconceived notions about life. We have to broaden our perspective, acknowledging that life's diversity might extend beyond the parameters we are familiar with. This realization has profound implications for our search for extraterrestrial life. We've been scanning the cosmos for Earth-like planets, but what if life exists in forms and conditions we haven't yet considered? Perhaps we should also be looking at planets with sulphuric atmospheres or high-temperature environments. This journey into an alternate reality serves as a humbling reminder of life's resilience. Against all odds, life finds a way. It adapts, evolves, and persists. Whether it's in the crushing depths of our oceans, the freezing poles, or a hypothetical world where sulfuric acid is the air we breathe, life proves to be the ultimate testament to adaptability and resilience. This thought experiment challenges us to redefine life and its conditions, reminding us that life in all its forms is a testament to adaptability and resilience.